Oh, yeah.
Can you see it? Okay, let's go. Alright, now we're going to do some exam practice questions. This is on Connect. This was actually last year's exam, so it's a practice exam which is a past exam. So question 1 is of the non-calculator section. Usually starts off with simple-ish, straightforward kind of questions, not worded problems. So let's dissect exam questions. This is what you should do whenever you see an exam question. So question 1 says solve the following equations for x. When you see solve, you should be thinking inverse operations, because that's how we solve equations. We are going to use inverse operations in one form or another, right? And equations. So solving equations is related to inverse operations because we want to get what x equals to. So isolating x. And then when you look at the particular equation itself, what you do is, what type of equation is this? What type of equation is this, Nathan?
God, I'm hiding the camera. I shouldn't be thinking. Is it just algebra? Is it what?
Well, of course it's,
is that what you're asking? I don't know.
Of course it's algebraic, but let's look at what's inside the equation. X squared equals to 4x. So it's got an x squared in it, and it's got an x in it. What does that? Does that tell us anything? If it's got a squared in it, what type of function or equation is it related to?
Janine?
Quadratic.
Quadratic.
Hey, there we go.
Square tells us this is a quadratic. So there we go. We start thinking about, okay, we have to solve an equation. We're going to use inverse operations. Now, well, what's this equation that we have to solve? It's quadratic because there's a square in it, and that's the highest power. So there's no cube, there's nothing else. Therefore, it's quadratic. Now, what are our tools for solving quadratic equations? So we figure out what type it is. It's quadratic, and now that we know it's quadratic, there's a few options available to us. We can factorize. We can use the quadratic equation. Or if it's simple enough, we can just go ahead and do the inverse operations. And that's what I'm going to do. So I'm going to start off by writing the question in its original form. And then I'm going to put everything over to one side. What have I done here, Nathan?
I've made it a. Oh, what is it?
No, what did I do from this step to
Oh,
this
you took at 4x.
I took 4x on both sides, good. And that was the first step. So
Isn't-
now what can I do?
Doesn't this become like an equation or something? Like
It's
it-
already, an equation is anything with an equal
Oh,
sign
yeah,
in
that's
it,
right.
and these are all equations. But now I have an equation that I can,
Yeah.
I've taken one step towards solving it. How many marks is this worth? It's worth 2 marks.
Oh, God.
I haven't earned a mark yet, I think, because all I did was move 4x from one side to the other side. Now I can solve it. And I could use a quadratic equation, but it'll just make things unnecessarily complicated. So I'll go with factorizing, because I know I can pull out a common factor from this. And what would the common factor be out of x squared and 4x? One term is x squared, one term is 4x, or negative 4x. What's the common factor?
X.
X. And if I take out the common factor of x, what do I get left with? So taking out a common factor of x, what do I get left with out of the first? X. And what do I get left with out of the second term?
4.
And what's the sign of that 4?
It's a 50-50 chance. Come on, Janine.
It's not a 50-50 chance, it's a definite thing. Look at there's negative.
Take.
Of course.
Oh, yeah. No, I nailed it. Yeah.
The negative, because when you re-expand this,
Mm-hmm.
it's going to be x squared minus 4x. That's how you check factorizations. Now, what are the two solutions? It's a quadratic. Sorry, I forgot to mention. When you identify a quadratic, you should always know that there are two solutions. Because quadratics either have two solutions or none. So two solutions could also be the same solution twice, remember? We did the whole when it touches the x-axis, yeah. So either two or none. And this one looks like if it can be factorized, it'll always have 2. So x, what do we make x to get the whole expression equal to 0?
4.
Or?
Yeah.
4 or?
4 or
0. So those are our 2 solutions, and this is how you should answer this type of question. If you get to here, you probably get a mark. If you get to the solutions, 2 marks. I should double check this, but it might be one solution, one mark per solution as well. I will double check this. Okay, that's all for part 1. Now let's apply the same thinking. So the orange is the thinking that you should train yourself to do these questions, and apply that to part B, which is x cubed minus 2x squared minus 3x equals to 0. Now, what's the highest power in this expression, Nathan?
the cubed.
So what type of equation is it?
A. It's been so long since I've used these terms.
What type of fraction?
Oh God.
Janine, help him out. It's a cubic.
Cubic. Ah, that's quadratic cubic.
It's a cubic equation.
Yeah.
So in a cubic equation, how many solutions are there?
3. I don't know. 3.
3.
0 isn't one of them. Maybe. Yeah. 0.
Well, clearly, yeah.
Yeah.
For 0, then it's going to be 0. So 0 is one of them. But then to get the other 2, I need to factorize.
Mhm.
So 0 is one of them, but x is a common factor, right? Out of these 3 terms. So let's factorize. We'll start with the original expression. Okay, so I can factorize x out. What do I get left with? I'm going to factorize out an x.
2.
What do you mean 2?
Wait, so like 2x take 3 or something like that? No.
2x take 3. How about the first part?
Oh.
There's 3 terms.
Oh, so wait, is it x squared?
X squared?
Yeah, x squared.
Then
Take 2x.
take 2x.
Take 3.
Take 3. Okay. Now what type of equation is inside the brackets?
Perfect square. Some-
Not necessarily. Actually, no.
Oh.
What's the highest power in here?
Squared.
So what type of equation is it? If we just look at the brackets.
Quadratic.
So this is a quadratic.
So it's a quadratic inside a cubic.
Well, it's a cubic. We factor out an x.
Mm-hmm.
And this is, remember, this is the part that tells you one of the solutions is x equals to 0.
Mm-hmm.
And then there's 2 other solutions that we need to find, which are basically going to be the solutions to this quadratic. We can now ignore the x because we've dealt with it by taking it out. Now we can look at this and go, okay, do you remember how to find the solutions to a quadratic that looks like this?
No, I forgot. Forgotten a long time ago.
Factorize, or it's in the formula sheet that we can use. The quadratic formula. Depending on which one you've practiced more, doesn't really matter which way you go about it, as long as you get to the solutions. So I'm going to start by I'm going to show you how to factorize it first. And factorizing again is a matter of practice. So factorizing means I'm going to express this quadratic in terms of 2 factors. So I need to find 2 factors that add to give the middle term and multiply to give the last term. So 2 numbers that multiply to give minus 3. So factors of minus 3. What are 2? Let's think of numbers that multiply to give them minus 3.
1 and 3.
1 and 3.
3 and 1.
That's about it. But I need minus 3, so one of them has to be negative. It's either negative 1 and positive 3, or positive 1 and negative 3. So which ones add to give negative 2?
The 1, the negative 1 and 3.
Negative 1 plus 3 gives me 2.
Yeah.
Alright. 1 plus minus 3 gives me minus 2.
Mm-hmm.
So it's the second set of factors that we need. So x plus 1 and x minus 3 is the factorization.
Oh.
You can check this by expanding it again using the follow method. Right. So what are our solutions? We identified one of them as 0. Right, so those are our 3 solutions, 1 mark per solution. 3 marks. I'm just going to go back to this factorization thing and just talk a little bit more. How much time do we have left?
It's 5 minutes.
Cool. We're going to talk a little bit more about factorization. I think you guys, there are a few ways of doing this, but one of the ways was cross swords method, or basically if you have a quadratic expression like this, you need 2 factors, and you draw like something like this that will check your factorization. So you need 2 numbers here that are factors of -3. So we found that it was positive 1 and negative 3. So 1 and -3. And this is fairly straightforward to do in your head, but you can help if you draw up a table like this, basically check by multiplying downwards. So x times x is x squared. 1 times -3 is -3. And multiplying across, x times 1 is x. X times -3 is -3x. And then if you add these two, x plus -3x is -2x. And what you have here should be your original expression, x squared -3 -2x. Just these two are switched around. So once again, write up your table, do a check by multiplying downwards, and then multiplying across. So step 1, step 2, multiply across. And then step 3, add x terms. And this should give you your original expression. So this is a tool for factorization that I believe you guys learned this in year 9 or something.
Yeah, 8, 9, something like that.
Yeah. So if I do this again with the wrong numbers, so if I use x and -1 and x and 3, just to show you how this works, multiplying down, squared, multiplying down, -3, that's all good. Multiplying across is -x and 3x, and if I add them, -x plus 3x is 2x. So my original, that's not the original expression. It's close to it, but the middle term is positive, so it's not right. So I know that this is not the correct factorization. So that was just a quick recap on factorization. And if you need to revise this, I suggest you go to MathSpace and do some, or Khan Academy, and do some factorization exercises. Okay, I'm going to stop the video there and continue.